This is Tree Dr. Cassian Humphreys. I'm back where I started. My first podcast was on this Bridgetown property. And the topic for this session is on oasification. I tend to create a whole range of terms, new terms, to describe what I perceive as being better ways of thinking, better ways of communicating. Desertification is something we've all heard of. So what's the opposite of that? And I often create new words based on opposites. And in the course of my sharing, I'll cover ground there. I'll give other examples. So just a bit of the character that is sharing this stuff with you. I wanted to share with you, I'm wearing another tie. You may have observed I was wearing a tie on one of my earlier podcasts. I have a real passion for tartans. In my youth, I wore kilts, utility kilts as well as tartan kilts. I mean, I still wear them occasionally. I'm a bit of a nutter. I've spent years getting around on a DR 650 kilted, but that's another story. This is actually the national Australian tartan. So, oasification. Let's go for a walk. So just flipping the video around. I mean, you can see here a lovely stand of, some beautiful green trees. I mean, I've heard it said that green is actually the colour signature of the heart. I think that's an Eastern law, yogic type stuff. And that green, is the closest sort of frequency, if you like, to the love frequency. I don't know so much about that, but certainly it does it for me, as a tree man. I mean, that's a beautiful, beautiful, beautiful green. And it's a good example of, like plants, trees, exhibiting, pretty reasonable health. Green is an ultimate indicator of oasification. So coming back to our driveway, on this first session, I was focusing on this avenue of trees. And I made a mistake, really. When I first started this journey, I should have documented these trees just to show you their transition since I carried out a fairly basic treatment. But we'll walk up to this tree as an example to kick off. And there you can see, young tree. In actual fact, not so young, 7 years old this avenue is. And these trees, because of the compacted driveway, because of the compacted soil environment in the turf, and a lack of carbon, a lack of water, a lack of everything that goes with desertification, these trees have been stunted, but they've been hanging in there and they've been building resilience. And that's why these trees are worth investing in. They're already hardy. They already have flexed their muscle. Total respect. But like you can see, surrounding this tree, just beyond its drip line, or on the edge of its drip line, I've done a treatment. And essentially what that treatment was I went in with a fork and I tilled the soil just to get some air in. That was the kind of most strenuous bit, really. And then I made a soil moat. I harvested soil from another portion of the land and made a circular moat of soil, so that when I irrigated, the water would sit and seep, to help focus water into the root crown and root system of the tree. Bearing in mind, the tree was pretty much in granite before. With the tilling of the soil, that gets air, reoxygenates the soil. So when water goes in there, well, then the water is dissipated slowly and is held. If I was to water ground, such as this turf environment, the water would just seep off. And oftentimes when it does rain on such environments, there is no water penetration. It's on a slope, it just runs off. It gets down to maybe 2 or 3 mils and runs away. So it's not really getting into the roots of the plants. And that observation is also true of the irrigation system. You can see the irrigation line. So, by tilling the space, by, putting in the berm, the soil moat, then I also added, underneath the layer of pea straw, which you can see, underneath that I added material that I harvested from a nearby Phoenix marigum that we'll get a discussion later in this podcast. And the material that I harvested was essentially nature's biochar. And so, just going down closer to the tree, we can see if I pull back some of the pea straw and I put the pea straw on the surface to reflect sunlight, because there was so much microbiology in the material that I put in underneath. I wanted that microbiology to, already this material has started to interface with the soil, because I'm pulling soil up there as well as some of that material, which we'll have a closer look a little bit later when I go to the marrow tree. But essentially, what we have is carbon, biologically active, air, and water. The fundamental elements that plants need to succeed. I also actually gave this tree a dose of sea salt, which is a seaweed based sort of liquid, natural kind of a fertilizer, and that probably is why this plant has greened up so well. This treatment was only done in the last few weeks. So as a part of the subject of oasification, I just wanted to demonstrate to you a simple little technique, a simple little way of measuring soil compaction, and a simple tool that can be used. Here we have a camping peg. So like if I focus on the dirt road and I take this peg and I try and push into that, you can see I'm making no progress. I mean, this has been heavily compacted to support a dirt road, but this is the worst kind of growing environment we can give a tree. But then the same with the turf environment. I mean, you can see my treated area there, but adjacent to that, we can go and test it for ourselves. Just go and lean on a peg. See, there's resistance there. There's significant resistance there for me. I can push to another spot. Okay, a little bit less resistance there. Maybe a dandelion root opened up that portion of ground. But again, you can feel for yourself the resistance of the soil. And where there's heavy compaction, it's very hard. I mean, if I was to belly flop on this, if I was to face dive, I'm going to hurt myself. Whereas when we come to the treated area, bearing in mind this was tilled by fork, this has had a number of irrigations. I put in some of the beautiful chocolate gold, as I like to call it, that I harvested from the cavity of the marigum. And this material has been on the soil, for some weeks, and there's been a rain since I did this. But when I push into the ground here, it just falls into the ground. I mean, nature decompacts through fissures, creating fissures. This is an optimal growing environment for a plant. The colour of this plant, I wish I'd got footage on these plants before when I first arrived, just to do a comparative study. Incidentally, this species of plant is a Lagerstromia. And let's walk down the driveway and have a look at a few of the other trees. So yeah, same sort of a deal. And look, to be honest, each one of these treatments, because I had to harvest all the materials from site, the soil, for the berms, the material I use, I call it chocolate gold, which I harvested from the marigum, the carbon, and then the pea straw. I mean, this overall operation, I think, averaged about 45 minutes a tree. I was using a ride-on mower with a large plant tub, to carry the material across for each treatment. So it takes a bit of time, I mean, it's like anything which requires a bit of love, anything which requires focus, where the focus isn't just on money, on turning over coin, where the focus is on delivering, things take a bit longer, but the benefits are far more real. All of the trees are kicking on. These trees have only had one rainfall since I started this process. One dose of rain, and I gave each of them 5 cans of water in the process of basically charging the soil. I mean, even in a desertified soil environment, there's microbiology is still seeded, so to speak, in the ground, and all you need essentially is air and water to reactivate it. I mean, certainly adding biology like I did with the carbon would help with acceleration. Very, very simple process, a very, very simple operation. Because I use pea straw, there actually is seeds, pea seeds in the mix, and I mean, those plants activating and forming a ground cover would be a benefit. I mean, you can see there's one there, a pea, which has grown up, because they actually help with fixing nitrogen as well. And I mean, this tree is, making growth. There was no growth. There wasn't a single shoot on it. Timing and phenology comes into the story. But then coming over to this tree and its neighbour, these trees were in the beginning were the most stressed on site, and part of the reason for that, as well as all the issues around desertification, is there's some competition from these established eucalypts. I mean, gum trees are allelopathic. That means that they release chemicals into the soil that detracts from competitive plant growth. But there's plenty of native species, understory species, that still associate with gums. But I mean, these trees are definitely more stunted and stressed, and that is, because of that competition. But again, their colour has most certainly improved. Over to our Phoenix marigum and the source of the chocolate gold. This miracle tree I discussed in podcast 10. Zooming in on this Phoenix, this is a remnant snag. The main body of the original tree is long gone. Originally I saw this as a fork failure, but it looks like a historic tension failure, which the tree since optimized. Snagology is the study of snags. And so, looking at this woody material, we can see that there has been an active wood decay, what's known as a brown rot. And this is a fungal organism which digests cellulose but leaves the lignified cell wall. Lignin is essentially cement. It handles compressive loads in woody plants, whereas cellulose is there for offsetting tensile load. And so when you take cellulose out of wood, essentially what you have left is kind of the raw carbon. The same as with charcoal. When you burn wood, you burn out the cellulose, and what's left is the lignin. And it's the same with termites. The termites tend to target the cellulose, and what they leave behind is the lignified tissue. But this material, is an exceptional resource. This is essentially nature's biochar. If we get a bit closer and have a look at one of these pieces on the ground, you can see it almost looks like charcoal. And when I squeeze it and crush it, it's very brittle because there's no cellulose in the remains of it. It's very brittle. It turns to dust. But this is full of microbiology. I recognise that with the footage that I've just got, that I need to break here. Otherwise, this podcast will be too long. So this session makes up the first in the oasification story.